Well, hello, my little triglets. Welcome to Chapter 3. Chapter 3 has to do with quadratic functions. And don't forget, the first three letters of the word functions is fun. So quadratic functions, things like projectiles, like a football flying through the air, or a bullet, or a rocket, they can all be modeled by quadratic functions. So the basic quadratic function is ax squared plus bx plus c. This is a normal parabola. Okay, it's the general form. We'll put that down, general form, because there's also standard form, which is a little bit different. Now in general form, we have several things going on. And the first one is, actually these apply to standard form as well, but there's some general things about parabolas that you need to know. Is if A is positive, then the parabola opens up. If A is negative, then the parabola opens down. So a sad face. So when you have a negative attitude, you have a sad face all the time. The second thing I want you to know is the vertex is basically the high or low point. So we have a vertex here or a vertex there. It's that high point or low point. And 3 is the axis of symmetry. We always write it as x equals something, and that x is the x of the vertex. So you find your vertex first, and then the axis of symmetry is very simple. The fourth thing is you have a cute little formula, negative b over 2a. That cute little formula is how you find the x given the general form of the parabola. So you'd have to go back up here. Here's your a, b, and c. So negative b over 2a, you just plug that in, figure out the x, and then you substitute back in to find y. Okay, now let's write down the standard form. Standard form is nice because it gives you the vertex without having to work for it. So it's y equals a x minus h squared plus k. If you were to FOIL this out and work it out, it would turn into the general form. But in this form, it's kind of nice because h and k is the vertex. Okay, and remember it's the opposite of h because of that minus sign right there. So if it's negative 3 in there, it's really 3 as the vertex. The other thing you do, if you want to graph it, is to choose 2 other points. And you probably want to pick them on either side of the vertex. And that way you'll get a good picture of what it looks like. The other thing, let me go back up here just for a second. I want to mention one other thing. C here in this form is the y-intercept. So you can use that along with the vertex and then maybe do a mirror image to find what the picture looks like to actually graph it. Okay, next page, let's talk about the x and y intercepts. And the x and y intercepts are the points where they cross the x and y axis. Okay, and again, they're useful for when you want to try to graph. It's pretty much the same as when you have a line. If you want to find the x-intercept, then you need to make y equal to 0 and solve for x. If you want to find the y-intercept, you want to make x equal to 0 and solve for y. All right, Let's try some of these problems and see what we come up with here. Let's try an x and a y-intercept. Let's say I have f of x, which is another name for y, is equal to negative 2x minus 3 squared plus 8. Now this is in standard form, so the vertex is pretty simple. It's, well actually we're just going to find the x-intercept, so I don't need to worry about the vertex right now. So I'm going to put in 0 for y. Let's try to find the x-intercept. So 0 equals negative 2x minus 3 squared plus 8. And then we have to solve it for x. So first thing I'm going to do, subtract 8. And then I want to divide by negative 2. So I have 4 equals x minus 3 squared. And then the next thing we want to do is square root both sides. So let's put that in red here to show that that's an important step. Now when you square root both sides, you get plus or minus 2. Whenever you put your square root on both sides, you're going to add a plus or minus in there. And then we just have x minus 3 on the right. So we have to do this twice. We have to do it with a positive 2 and a negative 2. So I'm going to add 3 to both of those. So one answer is 5, the other one is 1. So 5, 0, and 1, 0. So that means it crosses the x-axis twice. So maybe it's a graph going like that, where here's your 1 and here's your 5. So that would be that one. Actually be upside down because of this. So let's change that. Get rid of this. And we'll make it like that. Let's make it proper. 1 and 5. All right, what about the y-intercept? Let's do that over here. The y-intercept, I have to make x equal to 0. So I say y equals negative 2, 0 minus 3 squared plus 8. So let's finish. Negative 3 squared is 9. And then negative 18 plus 8 is negative 10. So that means this would continue and hit negative 10 down here. So you write it as 0, negative 10. Because it is a point, it's an intercept, it's that point, you have to write it as a point, 0, negative 10. Okay, let me do one more thing, and let's double check how we did on this. The vertex would be 3, 8. 3, 8. So does that kind of look like if I go over 3 and up 8? So I didn't draw it tall enough, but it does make sense that you go over and to the right when you want to graph that. Okay, what about finding the vertex if we don't have it in that standard form, if we're in general form? So I have f of x equals negative x squared minus 2x plus 1. So remember, this is a, b, and c. So if we want to find the vertex, it's that cute little formula to start. So negative b would be positive 2 over 2a. Now a is negative 1, so that'd be negative 2. So the x part is negative 1. So I'm going to just start that parentheses because I know it has to be a point. Then I'm going to take negative 1 and plug it back in for x because we just found it to be x. So I have negative 1 squared minus 2 times negative 1 plus 1. So negative 1 squared is 1, negative out front, then I have plus 2 plus 1. So these cancel, I am just 2. So negative 1, 2 is the vertex. Okay, the y-intercept, that's pretty easy because it's that letter C. So we write it as 0, 1. Let's try to graph this then. Just given that information, I go negative 1 and up 2 is there for the vertex. 0, 1 is the y-intercept, so it must be a reflection. So what would we call that point? Since I went over 1 and up 1, then I need to go over 1 and up 1 to get there. So if I was at negative 1, I must be at negative 2, 1 for that point. Okay, so then we can just finish our parabola by drawing it that way. Now you're going to be asked to find the domain and range. Domain, remember, is the input, range is the output. Basically, what are your x's and what are your y possibilities? So the y value, if you look at this, I'm never above that point. This point right here, -1, 2. So my y values are always going to be less than or equal to 2. Now we could write it that way. What about domain? Domain means your x values, your right and left values. So I start here and I can go that way forever and that way forever because these arrows keep going right and left. So they go forever and ever. So the domain is any number along the x-axis. So if I have a point here, this I can label that with, maybe 5, -10, or whatever it's going to be. And then I'll have another one, 6, 7, 8, 9. It can go forever to the right and forever to the left. Now, mathematicians have fancy ways of labeling these things or to write them down. One way to say the range where y is less than or equal to 2, we're going to say it goes from -infinity, which is way down here forever, comma, and it goes to 2. Now, can it equal 2? Yes, because it's right on that 2. So we put a square bracket around it. The curved bracket means it's not equal to it, and we always put curved next to infinity because you never really quite get to infinity. All right, so we're going to practice doing this kind of notation. It's kind of fancy, it's kind of fun. I'm not going to be marking you down for it, but I want you to get used to it because they do use it in the upper level math classes. All right, that's it for now. See you in class. Don't forget, Trig loves you, so you need to love Trig back.